Okay, number 9. Given f of x is 3x squared and g of x is square root of x minus 5, find f plus g, f minus g, f times g, and f divided by g. Determine the domain for each function in interval notation. So let me write these functions. F of x is 3x squared. G of x is square root of x minus 5. Okay, so what's f plus g? 3x squared plus square root of x minus 5. Alright? Now, again, this is not a polynomial function. This isn't a polynomial, alright? Because polynomials can't have fractional exponents. They can't have negative exponents on the variable, and you can't have fractional exponents. Like if you just had the square root of x, that would be x to the 1/2. Okay, and that's no good. Okay. Now, of course, this does not equal square root of x minus square root of 5. Okay, don't do that either. But a polynomial doesn't have fractional exponents like that. It only has either 0 or positive integers as exponents. So this is not a polynomial function. So what is the domain? Well, the domain of f is just all real numbers, but this cannot be negative under the square root. Alright, you can have 0, square root of 0 is 0, that's okay. So x has to be greater than or equal to 5, right? X minus 5, in other words, must be greater than or equal to 0, so x is greater than or equal to 5. Alright, so that's going to be the domain for f plus g. So domain is 5, including 5, to positive infinity. Alright. F minus g is pretty much similar. That's equal to 3x squared minus square root of x minus 5. And the domain, once again, is the same. 5 to infinity, including 5. Alright. And f times g. So it's just 3x squared times square root of x minus 5. Alright. The only problem here would be if you have square root of a negative number again, so the domain is the same as before. X has to be greater than or equal to 5. Alright, and then f over g. So we've got 3x squared divided by square root of x minus 5. Now, the domain of f is all real numbers, but for g, the usual domain for g, of course, as we've been saying all along, is anything greater than or equal to 5. However, if x equals 5 here, you're going to have a 0 denominator. Alright, you can have the square root of 0 is fine, but when you put that in the denominator, that changes things a little bit. So x minus 5 has to be greater than 0. Cannot equal 0. So that means x must be greater than 5. Okay, so the domain of this is 5 to infinity. And not including 5. Alright. And there you go. Okay, number 11. Given f of x is 2x squared plus 1 and g of x is 3x minus 5. Find the following. And we have parts A through E. So Have you ever had a test yet in math where your professor says, oh, there's only going to be 5 questions on the test, don't sweat it, and then when you get the test, each question has like parts A through H or something? Yeah, I remember those days. So here's a problem like that. Okay, f of x is 2x squared plus 1. G of x is 3x minus 5. And part A. What is f composed with g of 2? F of g of 2. Okay. So g of 2 takes the place of x in f of x. All right. Well, what is g of 2? It's some number, right? So it's f of parentheses. Now you just plug in x equals 2 in g of x. 3 times 2 is 6 minus 5. Okay, so 3 times 2 minus 5. You could just put the answer in, but I'm writing it out so you can see what's going on. All right, so that's f of 1. 3 times 2 is 6 minus 5 is 1, so you're taking f of 1. All right, and that equals 2. Plug in 1 here for f of x. 2 times 1 squared plus 1. Again, I'm writing it out so you can see what's going on, but you could probably do this in your head, and that's equal to 3. All right, so the final answer is 3. And then part B. We have f composed with g of x, or f of g of x. So here we're just going to end up with a formula for a function. We're not going to end up with a numerical value, so we take f of, what's g of x? It's 3x minus 5. What is f of 3x minus 5? Well, you plug in 3x minus 5 in the x in f of x here, right there. So it's 2 times parentheses 3x minus 5, and you're squaring that x value there. The whole thing, think of that as being the x, plus 1. So this is equal to 2 times 9x squared minus 30x plus 25. So that's a minus b squared is a squared minus 2ab plus b squared. Okay, so there's your a squared minus 2ab plus b squared, and then plus 1. Okay, now in order of operations, you multiply before you add here. So you multiply 2 times all of that. You're going to get 18x squared minus 60x plus 50 plus 1. I'll just add those right away, and I get 51. Alright, so the plus 50 and then the plus 1. And that gives you, well, that gives you the answer. Okay. Alright. So some quick erasing here, and we'll get to part C.
Eventually.
Alright, let's do part C. G of f of x. So part B was f composed with g, and now part C is g composed with f. So this is g of 2x squared plus 1. Here's g of f of x. Hope you can see that. It's kind of, the Windex is messing it up a little bit. So you plug this 2x squared plus 1 right there in the x on g of x. So that's 3 times 2x squared plus 1 minus 5. All right. Wow, that looks bad. There we go. Okay, so this is equal to, distribute the 3 through, 6x squared plus 3 minus 5, and that equals 6x squared minus 2. Okay, that takes care of that one. Part D. We have g composed with g of x, g composed with itself, and they're using this notation here. It just means g of x, like that. And yeah, you can compose functions with themselves, no problem. G of x is 3x minus 5. 3x minus 5. So that's g of x. And then you plug in the 3x minus 5 into g, right? Into g of x right there. So this is equal to 3. And then you put 3x minus 5 right where the x is. And then don't forget to write minus 5 at the end. So 3x minus 5, and the x here is 3x minus 5. So that equals, distribute the 3 through, 9x squared minus 15 minus 5. 9x squared minus 15 minus 5. So that's finally 9x minus 20. Alright, so there's g composed with g. Dare I make a guess that the other one's f composed with f? Let's see. Ah yes, they're thinking, oh, it's f composed with f of negative 2. Ooh, okay. Well, let me do some quick erasing again. Okay. Part E. We have f composed with f at negative 2. So that equals f of negative 2. So that's f of, what's f of negative 2? Plug a negative 2 in there. So that's going to be 2 times negative 2 squared plus 1. That's equal to f of, this becomes 4, positive 4, times 2 is 8, 8 plus 1 is 9. Alright? F of 9. What's f of 9? Plug in a 9 there. 2 times 9 squared plus 1. And 9 times 9 is 81, times 2 is 162, plus 1, so that's 163. Alright, that takes care of number 11, multi-part. Number 13. For the following exercises, use each pair of functions to find f of g of x and g of f of x. Simplify your answers. So for 13 we have f of x equals square root of x plus 2 and g of x equals x squared plus 3. So let me write these down. F of x is square root of x plus 2, g of x x squared plus 3. So first f of g of x, or f composed with g, is f of, what is g of x? It's x squared plus 3, so that's what we put here inside the parentheses here. What is f of x squared plus 3? Plug the x squared plus 3 right there, and you get square root of x squared plus 3 under the radical, and then plus 2 outside the radical. You could write that as 2 plus square root of x squared plus 3, if you wish, and that would be equivalent. And that's about it. That's about all the simplifying we can do with this. Alright, so now g of f of x is g of square root of x plus 2 okay, and you take the square root of x plus 2, plug it into x over here in g, and you've got square root of x plus 2 in parentheses squared right there plus a 3. So this is in the form a plus b quantity squared is a squared plus, let's see, a squared would be just square root of x squared, that's x, plus 2 times this, 2 times ab, 2 times this times this. So that's going to be 2 times 2 is 4 times square root of x, plus b squared, or plus 2 squared is 4. And then the plus 3 at the end. So the only simplifying we can do here is adding the 4 and the 3. So that's x plus 4 square root of x plus 7. And that's it for that one. Number 15, f of x is the cube root of x, and g of x is x plus 1 over x cubed. Cube root of x, g of x is x plus 1 over x cubed. So f of g of x is f of x plus 1 over x cubed. That's equal to, well, plug that into right there in f, so you've got cube root of x plus 1 over x cubed. Alright? And that equals cube root of x plus 1 over cube root of x cubed. So if you have a root, an nth root of a over b, that equals the nth root of a over the nth root of b. Alright. Similarly, if you have the nth root of a times b, that equals the nth root of a times the nth root of b. Alright. So, anyway, the cube root of x cubed is just x. Alright. This is basically x cubed to the 1/3 power. Cube root is like 1/3 power. So, now this here, the numerator, can't be simplified any further, so we leave it. Cube root of x plus 1, and that's over x. Alright. And let me do, let's see, g of f of x, I'll do it over here. I'll make a little space here for that, so I don't have to take the time to erase all this. G of f of x is g of cube root of x. And so that's g of, well, that you plug that into g, right? So you plug the cube root of x there and there. So you've got the cube root of x plus 1. Those are The plus 1 is not under the radical, so don't do that. And then you've got the cube root of x cubed. So we have the cube root of x plus 1 all over x. All right. There we go. Number 17. We have f of x is 1 over x minus 4, and g of x is 2 over x plus 4. F of x is 1 over x minus 4. G of x is 2 over x. And then the plus 4 is not in the denominator. All right. So we have f of g of x first. So that's f of 2 over x plus 4. And so you plug in 2 over x plus 4 right there in f of x. So you got 1 over 2 over x plus 4, and then you have minus 4. So you can see what to do next. Pretty simply, you just go 1 over 2 over x, and then you've got the 4 minus 4 is 0. Now you have a complex fraction, so you flip the bottom one over and multiply by the top. So that's, the top is just 1 times, and then x over 2. So it's just x over 2. So I'm saying that f of g of x equals this. I have to put a little proviso here if x is not 0. Because of this right here, right? In the original, if x is 0, then the whole thing is undefined, all right? And you'll have basically a hole in the graph if you were to graph this. So if you graph this composite function right here, it'll look like x over 2 until you get to x equals 0, in which case you're going to have a hole there. It's not going to be defined, all right? So remember what you're saying. Don't just automatically write stuff down because it's like a algebra machine. You know, you've become an algebra machine. Remember to think about what you're writing down. Just look back and take a look. Does this make sense? Yeah. This equals this as long as x does not equal 0. Now if you graph this normally, this is y equals 1/2 x, which is a straight line with slope 1/2 and y-intercept at the origin. So it's going to look like a straight line, except when x equals 0, and at the origin there's going to be a hole there. All right. So that's why I put that if x does not equal 0. Okay, let's go on to g of f of x. G, that's g of, what's f of x? 1 over x minus 4. Okay, so you plug in 1 over x minus 4 into g, so that would be right there where the x is. So you've got 2 over 1 over x minus 4 plus 4. Alright. Let me squeeze in the bottom line here. You invert the fraction down below and multiply by the top. So 2 times, and then you've got x minus 4 over 1, or just 2 times the quantity x minus 4. and then you plus 4 at the end. Alright. So let me move it up here. So you distribute the 2 through, that's 2x minus 8 minus or plus a 4 at the end. Alright. So this is going to be 2x, and negative 8 plus 4 is negative 4. 2x minus 4. Okay. Now again, what might be a problem with this? If that x equals 4, you're going to have 1 over 0 in that fraction there in the denominator here, in the original expression. So it'll be undefined when x equals 4. So I'm going to say this function looks exactly like this. That's what I'm saying by equals, except, or if, x does not equal 4. Alright? So again, it looks just like a straight line until you get to x equals 4. And then you're going to have a hole in that line, all right? 1 point's going to be missing from that line when x equals 4. Okay? All right. Okay, number 19. They're going nuts here. They're going nuts. Find f of g of h of x. Oh my gosh, and simplify your answer. Is that even possible? This is one of those unsolved problems from the history of mathematics, but guess what? We're going to solve it, okay? So, let's see. Got a lot of writing to do here. F of x is x squared plus 1. G of x is 1 over x. And h of x is x plus 3. Fortunately, each of these is not too bad, not too difficult. So they had a little mercy with us, didn't they? Thank you, author, whoever you are, or authors. Okay, let's see. Okay, FGH, f of g of h of x. Let's see, I've got 3 opening parentheses, I need 3 closing parentheses, like that, okay? And wait till you get into advanced math where you see parentheses, dot, 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 parentheses, then you know you're in some heavy stuff. Okay, so we've got f, well, what's the innermost function? H of x, so we're going to write that out specifically, but we'll write f and g here. Let's see, f of g of, okay, now what's the innermost? H of x, x plus 3. So, there you go. Alright, now what is g of x plus 3? Can we do this in our head? Yeah, that's not too bad. You take the x plus 3, right there, put it into the function g right there. So 1 over x plus 3. Alright, that's pretty easy. F over, not f over, but f of 1 over x plus 3. There we go. Alright. Well, now it's becoming more like a regular composition function problem. So you take f of this, right? 1 over x plus 3, put it into f right there. So you've got 1 over x plus 3 quantity squared. And then the plus 1. Okay. So if you have a fraction that's being squared, like this, a over b squared, or that could be any other power too for that matter, that's a squared over b squared. Alright. It's like similar to the rule a times b squared is a squared times b squared. Alright, so remember those rules. So you're going to have 1 squared, which is 1, over x plus 3 quantity squared. Alright, so what is x plus 3 quantity squared? 1 over this squared plus 2 times this plus that squared, right? A squared plus 2ab plus b squared, remember that? So x squared plus 2 times 3 is 6 times x is 6x plus 3 squared, which is 9. Alright. Now we're not completely simplified. We want just one fraction. Alright. So this is simple. It's just 1. So I can write that with a common denominator. That whole thing there is the common denominator. Okay, so this is going to be written as x squared plus 6x plus 9 over x squared plus 6x plus 9. Alright, so x squared plus 6x plus 9. And then the 1 is written as x squared plus 6x plus 9 over x squared plus 6x plus 9. Alright? Now, they both have the same denominator, so all you have to do is add the numerators. So you got 1 plus all of that, alright? X squared plus 6x plus 9. And that's written all over the common denominator. X squared plus 6x plus 9. And now you just add like terms on top here. 1 and the 9 is 10, right? So you've got x squared plus 6x plus 10 over x squared plus 6x plus 9. Alright? And voila! There you have it. That's it. Not too bad. Not too bad.